Solving one-step equations using the do-undo box strategy. So when we solve an equation, what we're doing is trying to find the value of the unknown variable so that both sides of the equation are equal. So we want 3 plus x to be equal to 17. So we want to see 17 and 17 on both sides of the equal sign. So what must x be to make both sides of this equation equal? So when I look at this equation, 3 plus x equals 17, I know just in my head, I don't need to do any further math, but I know that x has got to equal 14 in order for the left side of the equation to be equal to the right side. So when I add 3 plus 14 and equals 17, I can check it by saying, well, 3 plus 14 is 17, and 17 is equal to 17. So therefore, I have solved the equation correctly. But what if it's not so obvious? What if it's not so obvious what the value of x should be in my equation? Well, what we need to do is we need to follow a process to find the value of x in any equation. Let's go with our original equation of 3 plus x equals 14. And let's use the do and undo box strategy to solve this equation. So you'll see the first thing that I did is I set up a box and I made two columns, the do column and the undo column. In the do column, I'm simply going to write, what are we doing to the variable? So what are we doing to the variable? We're adding 3 to the variable. Now, in order to undo that, in order to undo adding 3, we would do the opposite, which would be to subtract 3. So we undo adding 3 by subtracting 3. And this is an important concept because when we solve equations, we are going to be working on using inverse operations. Inverse operations. An inverse operation is simply the opposite. So if I add, the inverse operation is to subtract. If I multiply, the inverse operation is to divide. Here we have another equation, x minus 2 equals 27. You can see that I drew my box. I have two columns, do and undo. Let's look at the do column. What is going on with the variable? What's happening to the variable? Well, we can see that the variable is being reduced by 2. So we're subtracting 2 from x. Now, in order to undo that operation, we would add 2. Okay, we would add 2. Let's look at another equation. 12 plus x equals negative 30. I have my box with my columns labeled do and undo. What am I doing to the variable in this equation? In this equation, I am adding 12. To undo that, I would be subtracting 12. Here's another one-step equation, but it's multiplication. We can see that it's multiplication because we have this term called 3x. 3 is the coefficient, x is the variable. 3 and x are being multiplied together. So I look at my do and undo box, and I can write down what is going on with the variable. Well, the variable is being multiplied by 3. And how would we undo that? Well, we would divide by 3. So we're using this concept of inverse operations. The opposite of multiplication is division. Let's try another multiplication one-step equation. we can see that we have 25 times x is equal to 100. I have my do column and my undo column. So in this example, what is happening with x? Well, x is being multiplied by 25. Now, what do we need to do to undo that? Well, we need to divide by 25. Now we have a different type of one-step equation. We have division. We have x divided by 5 equals 8. So what is happening with the variable? What can we write in our do column? Well, the variable is being divided by 5. And how would we undo that? We would undo that by multiplying by 5. Okay, so we've learned about do and undo boxes. Well, what do we use those for? How do we use the do and undo boxes to solve an equation? Well, let's look at an equation. Let's look at this one. 12 plus x equals 15. So if we do our do and undo box, we have adding 12 to the do column, and to the undo column, we would subtract 12. Okay? So what that means is currently we are adding 12. To undo that, we would subtract 12. So let's look and see how we would solve this equation. The first thing we do when we solve an equation is to circle the variable, and that makes us focus on what we're solving for. We're trying to solve for the value of x by moving all the other terms on the other side of the equal sign, and we do that using the do and undo box. So in order to get x all by itself, we're going to do the operation in our undo box, in our undo side of the box. So that means I would subtract 12 from this side of the equation, and what you do to one side of the equation, you have to do to the other side. So I would subtract 12 from both sides of the equation. When I subtract 12 from positive 12, I get 0. So we get x equals 15 minus 12, which is 3. X equals 3. When we solve an equation, the most important part of the equation is to check it. Check to see if our value of x works. So when we plug x in, we get 12 plus 3 equals 15. And I know that 12 plus 3 equals 15, and 15 equals 15. So I have checked my answer of x equals 3, and it looks good. Let's try solving another equation. What about x minus 5 equals 10? We have our do and undo box. I'm going to just write these down instead of drawing the box. What's happening to the x? Well, x is being subtracted by 5. Or 5 is being subtracted from x. To undo this, we would have to add 5. So let's rewrite our equation. X minus 5 equals 10. So I'm going to take whatever it says in my undo column, and I'm going to apply that to both sides of my equation. So my undo column says if I add 5 to both sides of the equation, I can get x by itself, because negative 5 plus positive 5 is 0. So x equals 15. Remember, we want to go back and check this, and so we want to take our x equals 15 and plug it into the original equation. So 15 minus 5 equals 10. 15 minus 5 is 10. 10 equals 10, so I agree with that answer. Let's summarize what we've learned. Well, the first thing I want you to know is that we use inverse operations in order to isolate our variable, or to get x or whatever variable you're working on by itself. So we're using inverse operations. So we remember that the inverse of addition is subtraction. The inverse of multiplication is division. So this concept of inverse operations is very important to understand when we're solving. Now, in order to figure out what inverse operation we need to use, we talked about the do and undo box. So whatever we write in our undo box is what we're going to do to get x by itself in a one-step equation. Finally, the third thing I want you to think about is that you always need to check your answer. And you check your answer by substituting, by using substitution, or testing your answer by plugging it back in to the original equation.